Now in this video, I'm going to quickly do a reply to the comments that were posted on the last video, which is your 2023 Chemistry O-Level Practical Paper. Now before I address any of the comments, I want to issue a disclaimer, which is that I do not have the marking scheme for this practical exam. And even if I did, I would tell you that I don't. So for comments that are asking how many marks will you get if you were to use this method, or how many marks will be deducted if you made this mistake, honestly, I don't know. I can only give you my opinion, which may or may not be correct. Now, due to the volume of comments, what I'm going to do is I'm going to go from one question to another. So I'm not going, if I were to go through the entire list of comments, it's going to take a very, very long time. So what I will do is I'm going to go question by question. I'm going to start with the planning question, so comments related to the planning question, before working backwards to the gravimetric experiment, to QA, and then the clock experiment. So a common comment with regards to the planning question is, what happens if you were to use simple distillation instead? Personally, I think that simple distillation is acceptable. Reason being that the liquid that we are trying to get is propanol, and the boiling point between propanol and the next other liquid, which is water, is and propanoic acid, is actually large enough. So even if you were to use simple distillation, you should be able to get propanol to a relatively high purity. But again, that's just my opinion. Another comment would be whether will you be able to use a conical flask instead of a round bottom flask? The answer is yes. I think the container of the mixture is not important, so you may also use a conical flask. However, there was one comment which I thought was very, very good, which is this. So for planning, I put a round bottom flask in a water bath. That is the ideal setup. Reason being, we are separating a mixture of liquids, and there are organic liquids in there. Organic compounds are all flammable. So it will be ideal to use a water bath to heat the mixture instead. So now looking at this comment, I would want to go back to change my answer into a water bath, a round bottom flask in a water bath. However, within the knowledge of your high school lab, I think most of y'all would actually just use a Bunsen flame and a tripod, which I think is the normal setup in a high school lab. But having said that, there are limitations to using a water bath, which is this. In this context, we are only trying to get propanol, where the boiling point is below 100 degrees. In the event where we are trying to distill a liquid that has a boiling point of above 100 degrees Celsius, then you can no longer use a water bath, because in a water bath, the temperature of your mixture will not go beyond 100 degrees Celsius. But for this particular question, it's perfectly fine. In fact, it's ideal to use a water bath. There was a comment on a strange method that involved heating the mixture until 49 degrees Celsius and then condensing the gas in a condenser. I'm not sure how this will be marked, but in the event where the setup looks legit, meaning that the flask and the condenser is connected in an airtight manner, then I think it will be okay. Okay, but in the event where your flask containing the mixture and the condenser is not airtight, meaning your propanol, when it boils, it actually escapes into the surroundings rather than to go into the condenser, then it will not be accepted. There were also many comments on the last part of the question where you're supposed to test for the presence of propanoic acid. Some methods include adding of alcohol and then to detect a sweet smelling liquid. This one is not correct because usually for esterification you need to add concentrated sulfuric acid, and on top of that you need to heat before the ester is formed. So by simply adding an alcohol you will not get any ester. There was also a comment asking about potassium manganate 7. This is not correct at all. Reason being, potassium manganate 7 is an oxidizing agent and propanoic acid can no longer be further oxidized. So there should be no reaction. Acidified potassium manganate 7 would be an ideal reagent to test for propanol or propanol, because these two organic compounds can be further oxidized to propanoic acid. So you will detect a color change from purple to colorless. There is also a very good comment which is asking about whether the addition of magnesium ribbon can be accepted, because magnesium ribbon can potentially react with water to form bubbles as well. So we wouldn't know whether propanoic acid is indeed present or is your magnesium actually reacting with water. Now this question actually got me thinking, and it actually opened up a can of worms. Why is that so? Because when I first read this question and I look back at the context of the question where we are performing a distillation to obtain propanol, so the first thought that came to mind is that if you perform a fractional distillation, the propanol that you get would not contain any water, or even if it did, it will be present in very small amounts. So in that context, your magnesium will not react with the water. So any bubbles formed must be due to the reaction with your propanoic acid. But then again, in the chapter of acids and bases, we learned something very important, which is that water is essential for any acids to exhibit the characteristics of an acid. So if there were no water present, or if the setter intended for this context of the question to have no water present, then the only correct answer would be adding an aqueous carbonate, for example aqueous sodium carbonate, so that there's water present. Only then would your propanoic acid ionize in water to produce hydrogen ions that will then react with sodium carbonate to produce bubbles. So if that is the case, adding of any metal or any solid carbonates would not be correct, because if there's no water present, your propanoic acid will be in its unionized state. It is not going to react with any metal or carbonates. As to what the correct answer is, I have no idea at this point in time. So it really depends on what the setter had intended the question, the context of the question to be. Next, we'll move on to the gravimetric experiment. This is the one that shocked many of you, because the final mass is actually larger than the initial mass, because many of you all forgot to add in the mass of the mineral. Now, the common question is, will you get ECF if you use the wrong mass? The answer is yes. So even if you have a random wrong value of mass and you use that value and your subsequent calculations, the methods are correct, the calculations are correct, you will get ECF. Next, we'll go on to the QA experiment. In the QA experiment, there was a comment asking whether there's a need to test for chlorine gas in question 2. Now, since question 2, solid solid C is a mixture of copper 2 carbonate and hydrated copper 2 chloride, So upon heating, would your copper 2 chloride decompose to give you chlorine gas? The answer is no. Now, not all solids will decompose upon heating with the Bunsen flame. For copper 2 chloride, I think if you heat it strongly enough, it would melt before it actually decomposes. That I'm not sure. I need to check the melting point and the decomposition temperature. But under the Bunsen flame, what I'm quite sure is that your copper 2 chloride does not decompose to form chlorine gas. In our syllabus, there are only two salts that can potentially decompose under the Bunsen flame. One of them would be your carbonates, the other one is nitrates. But nitrates would rarely be encountered in the lab because if you decompose it, it may produce nitrogen dioxide, which is not very friendly. And along the same lines, it's unlikely that a QA test would produce large quantities of chlorine because chlorine is not exactly very friendly as well. Furthermore, in our lab, most of the time chlorine gas is produced by adding hydrochloric acid to bleach solution. So what is actually happening is that your bleach, being sodium hypochlorite, will react with hydrochloric acid to form chlorine gas, and that reaction, for those of you who read extensively, it's a comproportionation reaction. Now, even if you are unsure, should chlorine gas be produced in the lab, you should be able to smell it. Or if everyone is producing chlorine gas in the lab would suddenly smell like the swimming pool. So if you didn't detect the smell, very unlikely that chlorine has been produced. The last question that we will look at is the clock experiment. The clock experiment, many comments were asking about the plot, whether it's a line, it's a curve. Many teachers say there is a curve. For that, I am very sure that the correct answer, I'm not saying the only accepted answer, but the correct answer is a straight line with anomalous points. In higher levels, you will learn something called the rate order, or the order of reaction with respect to rate. And for this particular clock experiment where hydrochloric acid reacts with sodium thiosulfate, the rate of reaction is actually first order with respect to the sodium thiosulfate, meaning the plot of rate against concentration of sodium thiosulfate should be a straight line. There was also another comment that's asking about the stoichiometry between sodium thiosulfate and hydrochloric acid being 1:2. However, from what I can remember, there isn't any part to the question that requires you to compare mole ratio. So I'm not sure why would the stoichiometry or the mole ratio between sodium thiosulfate and hydrochloric acid be called into consideration for any part of the question. However, if you were to perform a chemical calculation, for example, if you are given the amount of one and then you're supposed to find the amount of the other, then only then do you need to consider the mole ratio. Another popular comment or question is asking whether if the answer where you add water simply to change the concentration of B, would it be accepted? For that, I am not sure. Personally, I don't think that's a good enough answer, because by simply varying the volumes of B used, you are already changing the concentration. So why is there a need to add water? The reason is so that the total volume of the solution remains the same, and the volume of B used is directly proportional to the concentration of B. That's one important aspect of why the total volume must be kept constant. There was also this comment asking whether if they got the concentration of B in experiment 1 wrong, but they used the value and divided it by 5 to get the concentration of B in experiment 2, will you get the marks? The answer is yes. Again, if there's no error in your calculation, you should get error carry forward for that. Okay, the last popular comment would be that of percentage uncertainty. Is it okay to be plus minus 2%? Usually when we write percentage uncertainty, we don't put a plus and minus only when we are talking about absolute uncertainties. But in this case, I don't think it will be penalized, but again, I'm not sure. So I hope I have addressed most, if not all, the comments in this video. Once again, the practical is over. It constitutes 20% of your final grade. Even if you haven't done well, it's time to focus on your paper 2 and paper 1. And once again, all the best for your